day 7, we're going to be going back and talking about Pythagorean theorem, and we're also going to be talking about the relationships in the special right triangles. I will probably split this over 2 videos as well, just so you know. In this case, both of them are mandatory. So based on what you already know about the Pythagorean theorem, you know that it only works for right triangles. If you do not have a right angle in your triangle, it's not a right triangle, and you cannot say that you are doing a squared plus b squared equals c squared because you would not have a hypotenuse to put in for c. The a and the b in the formula are completely interchangeable, but the longest side, which is called the hypotenuse, also found across from the right angle, has to go in for c. So make sure that you're putting that in there for c. Now, in the past, we've used Pythagorean theorem to solve for the missing sides in triangles. In this case, we're going to take a little bit different approach to this, and for question number 1, they're asking you, are these the sides of a right triangle? So when I go through and do this, I have to go in and say, if these 3 really are side lengths of a right triangle, then when I substitute them into Pythagorean theorem, what's going to happen is that the Pythagorean theorem will hold true. So in here, I know that I have a side of radical 7, and I have a side of 2 radical 6, and I have a side of radical 31. Remember, when you plug into Pythagorean theorem, you have to make sure that the longest side, the one across from the right angle, the hypotenuse, goes in for c. So I'm going to, on my calculator, figure out what these decimal values are, and they're rounded, but we at least have a good idea, so that I know for sure that I am putting the longest side in for c. So when I substitute into Pythagorean theorem, a squared plus b squared equals c squared, I have radical 7 squared plus 2 radical 6 squared equals radical 31 squared. Now, at first glance, you may think that this looks extremely difficult, but remember, if we have radical 7 squared, that's just 7. 2 radical 6 squared, I'm going to square the 2 and get 4, square the radical 6 and get 6, and then radical 31 squared is 31. So in this case, when I go through and do the math, I find out that 31 does equal 31, so Pythagorean theorem holds true. So the answer to my question, is this a right triangle, is yes, because the side lengths make, and I'm going to put PT for Pythagorean theorem, true. If you had gone through and done this and you didn't get that the 2 sides were both equal to each other, in other words, you didn't get that the a squared plus b squared was equal to c squared, then you would say, no, these sides can't be the sides of a right triangle. Question number 3 is a question that came out of the Common Core binder, so it's something that they think that you should be able to understand. I'm going to go through and do this with you. I think it's a little challenging kind of to see what's going on, but based on the background that you've had over the past few days, it's probably not going to be terrible. So if you look up here at the right triangle that they have drawn, they have the side of A, the side of B, and then the side of C that's over here. I'm actually going to use that same triangle, but I'm going to take it and I'm going to rotate it. When I rotate it for my drawing for number 3, I'm going to rotate it in such a way that when I go through and do this, I have the hypotenuse side down. So I'm going to take this and I'm going to rotate it like this so that the hypotenuse is side down. So here's where the hypotenuse is, side down. Here's B, and then here's A. So this is my side of C, this is my side of B, this is my side of A, and here's the right angle. The reason why I'm choosing to look at my triangle this way is because in this, I'm going to go through and draw in an altitude. When I draw in the altitude, which I'll call A in this case, I also have, when that altitude is drawn in, 2 parts that my hypotenuse is separated into. So that hypotenuse of C is separated into two parts. I chose to use this drawing because we're going to use something that you are already very comfortable with, and that's the idea of the leg 1 and the leg 2. So in this, if I focused on this leg 1 that we have right here, I know that if that's what I'm using with a leg 1, I would use the formula leg 1 and leg 1 in the means position, part 1, and the whole hypotenuse in the extremes position. And then I substitute in what I know. I realize that we have some variables in here, but that's what we're going to actually put in. So my leg 1 is B. So I'm going to put that in here. My part 1 I just chose to label Y. And then my whole hypotenuse has a C on it. And I'm going to leave that formula just like this. And then I'm going to go back and I'm going to talk about the other leg. And we know that the other leg is A. And we've talked about how when we're working with leg 2, we use part 2 of the hypotenuse and the whole hypotenuse. I'm going to go back and substitute in what I know. Leg 2 is A. Part 2 of the hypotenuse is X. That's the part that's closest to it. And the whole hypotenuse is C. Now, the reason why I've chosen to go through and do this is because we can maneuver these proportions around and get an outcome that actually goes through and proves the Pythagorean theorem. So the first thing that I'm going to do is I'm going to go back and I'm going to cross multiply the first proportion. So when I cross multiply, I get that B times B, which is B squared, equals C times Y. And then, if I go back and I cross multiply the second equation, I get A times A, which is A squared, which is C times X. And what I'm going to do from this point is, I'm actually going to add these two equations together. So when I go through and I add these two together, here's what I'm going to do. I'm going to take this blue one and I'm going to write it underneath this one. And I'm going to add the equations together. So when I go back now and I add these two equations together, I end up with, on the left-hand side of the equals, B squared plus A squared, which I'm going to choose to write as A squared plus B squared. And on the other side, I have C times X plus C times Y. So if my goal is to go through and prove Pythagorean theorem, I'm doing a pretty good job with what I have over on the left-hand side of my equation. Now I have to kind of work with the right-hand side. So if I continue on, I'm going to keep the left-hand side the way that it is, and I'm going to factor a C out of my two terms over here. And when I factor out a C, I have X plus Y. And then I'm going to go back and take a look at my original picture. And in my original picture, we have this hypotenuse that's broken into two parts called Y and X. And if I add Y and X together, that equals the whole thing. And the whole thing is what we call Y. So in here, A squared plus B squared equals C times X plus Y, which is also C. And when I go through and simplify, I end up with C times C, which is C squared. So I have essentially used the proportions for similar triangles that occur when an altitude is drawn into the hypotenuse of the right triangle. I set them up, add the two equations together, which is a legal step in algebra, and then went through and proved that A squared plus B squared was equal to C squared. If you turn your paper over, I am going to continue on with at least part of the rest of the notes for today. So next page talks about special right triangles. In special right triangles, there's two different kinds that we can talk about. One of the two kinds is a 45, 45, 90 right triangle. And the reason why we know that this right triangle of 45, 45, and 90 has two congruent sides, which are already marked for us, is because it has two congruent angles. And the rule for this is that whatever this side is that's across from one of the 45s, so you can see I'm kind of going across the triangle, whatever that side is, which we call A, we know that this side is A also because those two sides are congruent. So whatever's across from one of the 45s has to be across from the other. If we're looking for the side that's across from the 90-degree angle, I'm going to take that side of A and I'm going to multiply it by radical 2. Every single time, this is how this problem or process works. So if I tell you, let's suppose that A is 3, then this side would be 3 also, and this side would be 3 radical 2. So it works that way every single time. So if we take a look at what's going on over here in this table, these are the lengths of the legs. This is the length of the hypotenuse. So if we know that the legs are both 2, the hypotenuse is 2 radical 2. If the legs are 3, it's 3 radical 2. If the legs are 4, 4 radical 2, and so on. So if we take this idea now and we put it into a rule, in the rule, it says that if we know that we have a 45, 45, 90 triangle and the legs are congruent, the length of the hypotenuse h, which is what we have over here, our hypotenuse, is radical 2 times whatever the leg is. And again, that rule, whatever the two congruent sides are in our 45, 45, 90 triangle, the hypotenuse will be that measurement times the square root of 2. If I give you a little example of this, if this is a 45, 45, 90 triangle, these two sides are the same. If I told you that this side was 5 radical 2, that would mean that each of these sides, which are the A sides, would be 5. So if this side is A radical 2, then A must be 5. So let's take a look at a couple of examples here. In question A, they're telling us that we have a 90-degree angle, a 45-degree angle, so by default we know this is 45. So this is a 45, 45, 90 triangle. The side across from the 90 is the A radical 2 side. This side of 6 is what A is. So my answer to this question for what X is 6 radical 2. In question B, this is my side of A that's given. They probably should have marked those congruent, although we know that because these 9 radical 2's are here. This side of X is my A radical 2 side. Remember that A in this case is 9 radical 2. So this is 9 radical 2 times radical 2, which will give you 18. For question C, this one is a little bit different because they're giving me the A radical 2 side. So they're telling me that A radical 2 is equal to 18. I need to go through and solve by dividing both sides by radical 2. So I end up getting 18 divided by radical 2 is my answer. That is not, however, my final answer because remember you can't leave a radical in the denominator. So I need to multiply by radical 2 over radical 2, which gives me 18 radical 2 over 2, which gives me 9 radical 2. So this side length will be 9 radical 2. So you have to pay close attention to what it is that they're giving you as far as which way to work on this. So at this point, I'd like you to take a couple of minutes, work on D, E, and F, and I will start the next video with the answers to those 3 questions. And then we'll go on to the other kind of special right triangles.